All right, kiddos, so we are going to be starting off with our motion packet. Open that up. Position, velocity, acceleration. Some of you have been working on it, some of you have not. It is what it is. But as we do, also, I've asked you guys to grab out your 2012 that you were supposed to pick up yesterday. The 2012 Practice AP, which is a bonus AP I printed for you, especially for those of you guys that are not taking any APs until ours. That way we can really get some good work done, but those who are taking APs don't have to be terribly stressed with lots of deadlines and lots of due dates, etc., etc., etc. I'm going to your guys' shared folder, and I'm also turning on, there we go. Hopefully it's coming up. Yes, it is. Let me get your guys' laying the foundation out. Right now I have period 6 is out. Laying the foundation, period 1.
Is the motion on the position velocity and acceleration packet?
Yes. Yes, so I'm calling the position, velocity, acceleration packet the motion packet, but I did call it properly in your shared folder. I got that answer key up yesterday. Don't worry, I'm here for 2 reasons. Handouts assignments is where we've been doing all the laying the foundation stuff. I was going to post all the reviews up here. I just haven't gotten a chance. I need to go in the office and scan, and it just takes time, and I haven't had my free periods really. But I do have the keys for all of them, including, there we go, number 9, position, velocity, acceleration. I think it says number 9 in your packet too. So that key is in there, and then I'll also talk to you guys about the key for, I went back too far, the 2012 in a second. So I did promise you guys about 10 minutes of questions. So is there anything in the position, velocity, acceleration packet you guys want me to talk through? Ready, set, go. Number 1, FRQ or multiple choice. Did you guys see this really cool when you see think, just like everything motion in one page? That might be a good thing to look at. You guys have hopefully kind of filled out some of them or gotten them in your forever cards, but still, all good clue words, right? All good clue words. And then there are some good examples as well, but let's just go ahead and go to number 1. This is a classic motion problem. One of the first things you guys need to see when doing a motion problem is identifying what you've been given. Like, I have a velocity equation, what they're asking for, like how many meters. Guys, if this is velocity, what would meters be measuring? Distance, good. Distance or position, change in position. And then if it gives me 2 times, is that an at integration is net change, or is that an over an integral? It's just an over. So it's just from 1 to 8. Why am I integrating velocity? Because I'm trying to get to position. Does that make sense? So this is a classic, ready, forever card, displacement problem. What's the change in distance? Not total distance traveled. Not total distance traveled. Said how many meters did the particle travel? They didn't ask for total distance traveled as in back and forth. How many meters did it travel? I think they're just asking for displacement. They try to be very clear when it's total distance absolute value. So we would need to, oh, it's by hand. That's no fun. Integrate by hand, but the nice thing is it is just power rule, right? So I'm just going to go pretty quick here because we've already talked about how to solve a definite integral. We have to integrate first. Adding 3 over 3 is 5 over 3 times 3 over 5. Well, that's nice. The 5's canceled. And then plus 6t squared over 2, which would be 3t squared. And we're doing this from 1 to 8. This is where some of you guys get caught up just a little bit in the exponents, but let me try to show you at least a little bit easier way to think about exponents. There's 2 ways that kind of help. And we have 3 times 8 squared, plugging in f of b minus f of a. First of all, what is 1 to any power? Just 1. So we don't have to worry about the 1 to the 5/3. It's just going to be 1 times 3 is 3. That one's also going to be 3. So I have 3 plus 3 there, so I have minus 6. In the beginning, this isn't very pretty. Except we have 2 ways of thinking about it. For those of you guys that are like fractional exponents, they're going to be on the AP somewhere. You can think about this either as 8 to the 5/3. How do you think about it? Either it's 8 to the 1 2/3, which would be 8 cubed root of 8 squared. Or you could think about it as 2 cubed to the 2/3. Why is that nice?
Because the 3's cancel.
Power to a power, you multiply. So you end up just with 4. Because 8 is 2 cubed. Oh, wait. I did 2/3 instead of 5/3. Pause. I don't know what I was writing. There we go. 2 cubed to the 5/3, you multiply, so you get 2 to the 5th, which would not be 64. Sorry, which would not be 4. 2 to the 5th would be, well, that would be 64, wouldn't it?
Yeah, you get like take the cube root of 8 and then 2 to the power 5. That could be cool.
Oh, struggle. Or 8 to the 5th cubed rooted. The problem is in that one, without a calculator, that's rough. You know what I mean?
So you can't like do it separately.
You could do 8 to the 5th. The problem is that's just huge, as opposed to seeing that it'd be 1 2/3. So that way you have a lot less math to do. Because then in this one you would have the cubed root of 64, which is 4 cubed. So then you'd have 32 that way. You have 32 that way. The problem with this one is you'd actually have to find 8 to the 5th, but you could. They all should be the same thing.
64 and 30.
Is it? 8 squared is 64. 64 is 4 cubed, right? 4 times 4 is 16. 16 times 4 is 64. And 8 times 4. Oh, it's cubed root. Yeah, it's cubed root. Sorry, it's cubed root. Yeah. If it was square root, you're right. That would be very different. But the cubed root makes all the difference. So then back over here. So I have 3 times 32, which would be 696, plus 3 times 64, 192. And then right away we're like, yeah, no. And then we're like, let's see, that would be 90 plus 192, which would be 282. 533 is way too big. That one's way too small. You have to kind of figure it out to narrow it down anymore.
I know I did everything right, so I forgot to multiply. I was doing it in my head, and I got 8 squared, and I did multiply by 3.
So easy to do. Do you guys have any other motion ones? You don't have to. I can ask again some more. Yeah. 3? Okay. Florence? 3, 2? You say 5? Okay. Alex?
7.
Okay. So let's do 3, 5, 7, and we'll stop there for today. So number 3. A particle moves along the x-axis with acceleration at any time t given as, okay, so we have an acceleration. The particle's initial velocity is 10. Its initial position is 2. What is the position function? Ooh, you guys had one of these on your mock AP. I think. How do you go from acceleration to position? Take the integral twice. So we have to say first of all, velocity, let's not use the marker. Velocity is equal to the integral of acceleration. I'm doing the indefinite integral. You could also do the definite integral and say we're starting at 0 and going to 10. No, sorry, starting at 0 going to t, but some of you would get confused by that. So instead we'll go ahead and just say, what do we have? T cubed over 3, cubed, 4t squared over 2, so 2t squared, 6t, and we can't forget our plus c. Do we have a find plus c from the column above? Yeah. Yes, we do. Initial velocity is 10. So we can say, we can plug in the point when t is 0, velocity is 10. That's going to lead us to 10 equals 0 plus 0 plus 0 plus c. And we know what c is. So when we go to find position by integrating one more time, we're going to integrate t cubed plus 2t squared plus 6t plus 10. I modeled this horribly for you guys. I forgot my DT. Remember, AP guys can take off on free response. You don't show your notation properly. Position, we end up with 1/4 t to the 4th. 2/3 t cubed. 3t squared. 10t, and don't forget your plus. Do we have a clue for that one too? Initial position is 2, so we're plugging in the point. When time is 0, position is 2, and that leads us to 2 is equal to 0 plus 0 plus 0 plus 0 plus c. So last but not least, our position is going to be all of this with a c of 2. And that's going to end up being 1/4 t to the 4th, 2/3 t cubed b, right? Checking, good. So to get from position to velocity, take a derivative. Position to acceleration, take 2 derivatives. Acceleration to velocity, 1 interval. Acceleration to position, 2. Don't forget your pluses. Number 5. Ooh, graphing calculator. Go team. So I'll probably just show you how to set it up, and then you just plug and chug, right? A bottle rocket. Oh, this just got exciting. It shot upwards from a 10-foot stand. Isn't that initial position? With a velocity of. What is the position after 2 seconds? AKA, what is x of 2? So they're not saying how far through the air has it flown. It's asking how high is it off the ground. Question, is this an over or is this an at? So they want to know where it is at or what has happened over. At. Now those two questions are very related, but they want to know where is it at. Just not just what has changed or how has it changed. Where is it at? So where is it at? What formula is that? Integration is net change. Good. So find the amount at B. Take the amount at A, which initial is what they gave us. And then you say from between 0 to 2 in those first 2 seconds. So in order to know how high the rocket is off the ground, we have to know how high it started, which was on a 10-foot stand. And how much has changed. What is the change in position between the 2 seconds as a result of velocity? Can we plug and chug that to our calculator, calculatrice, calculator? Yes. Are we solving that integral by hand? Let the calculator do it for you. Does anybody know what the final answer is? Check the answer key. So that's the right setup. Last but not least, number 7. Ooh. Love it. Look at all these words. The rocket is falling or rising. There are 2 categories of words. Falling or rising, and increasing, decreasing, or constant rate. Falling or rising. Does anybody know what we're looking at? The sign of what would tell us falling or rising? The sign of the positive or the sign of velocity. Remember how the sign of velocity, if velocity is positive, moving to the right, negative, moving to the left. What's different here? It's an up-down. So positive means you're going up, negative means you're coming down. But then the second category, increasing rate, decreasing rate, constant rate. How do we think about the rate increasing or decreasing? Look at the velocities derivative. Look at the velocities derivatives sign. And you know about, because all the rate, that just means velocity. Increasing, decreasing, I'm looking at velocities derivative for the increasing, decreasing test. So the long story short is all we have to do is plug in and say, I'm just looking at the top, sorry, what's V of 3 and what's V prime of 3? All I need to know are the signs. V of 3, 15 minus 1.6 times 3. I don't even need to plug it in my calculator. That's a positive number. V prime of 3. Maybe we should find V prime of t. V prime of t is equal to negative 1.6, I think. So it doesn't matter what the time is. It's a constant negative number. So velocity is positive and acceleration or velocity's derivative is negative.
Rising and decreasing.
Yep, the only calculus is rising at a decreasing rate. Positive velocity shows me rising, the negative acceleration shows me decreasing. Alright, cool kids. I might ask just a little bit at the beginning of tomorrow if there are any other questions on the motion packet. So if you want to work on it, we'll know it's totally fine. Some of you know motion is a struggle, but hopefully we can kind of work out the kinks. So let's go ahead and look at 2012 now. 2012, and then you miss AB, AP. I'm going to put this in class notes if you guys want to access this after today. And then you miss, let's see, period 1. So 2012, AB, AP. AP, AB, I don't know. Maybe I should rename that. You guys know that. Okay. Section A. And you guys have been working on multiple things. You might not have gotten a lot done, but in what you have gotten done, anybody out there? Oh man, I have like answer sheets and all sorts of things. Half of the answer sheets kind of you have to fill out information, like survey questions. And then this is the stuff that's going to get read to you. So if you guys want to see how exactly things are going to go, most of you are like, I don't like it. I'm just going to help me all get it. You may see students, oh, this is intense. Good thing this class does that. Okay, 1.5 will do it. Don't ask me. Huh? That's why we have those cool dividers. There we go. Section A. In whatever you tried. Any questions? 11. 6.
Can we see the answers?
6. What?
Can we see the answers as we go?
Yes. Oh, hold on, pause. Katrina just asked about seeing the answers. I forgot that I didn't actually show you what I was going to show you. And in doing so, some of you guys might want to take a picture if you want to access it during class. There are 2 places where you guys can find answers, okay? First of all, I did tell you yesterday you can search Mr. Calculus. You can technically search Mr. Well, hey, look, it's right there, 2012 practice test. You can also search Mr. Calculus 2012 Calculus AB. There you go. And what should come up is a place where on Mr. Calculus's website, BC is on the bottom. Don't do those. AB is on the top. And you can go ahead and access. And with his, it does have the answers at the end for every one, and he has typed out the formulas and even the procedures. He types his answers. He doesn't handwrite them. He types them for a lot of different reasons. But he does have the proper answer along with the reasoning as to why it is what it is. It goes by sections probably because of it. That's like the pages that he goes through. But he goes through all of the multiple choice. There's A, there's B. The free response, I believe, is just in a different section. So if you scroll down, 2012, here we go. Free response and multiple choice. Now, for an alternative to Mr. Calculus, you can go in the AP exam prep. You can go in the practice exams. This is technically what this is. I don't have it here because I printed it and gave it to you guys, but if you go under College Board exam keys, I did upload this morning a 2012 version. And this is where you can access really quickly. The section A goes 1 through 28. Section B goes 76 to 92. Remember, this was the old way of counting. Now it's 1 through 30 and 76 through, oh, stink, plus 15. What is that, 91? So the numbering is a little bit different. But there are the answers if you want to take a quick picture of them to see whether or not you got them right. But beyond the answers, here are also the AP answer guidelines for all the FRQs 1 through 6. And then underneath all of those, ooh, that's how you can figure out a 1, 2, 3, 4, 5. If you want to see how many you miss. It's awkward, but this teacher did it the same way I did to save paper, aka I kind of stole their idea. I was like, oh, that would save paper. But what's kind of awkward about this? You have to turn your head this way to see it. So it's handwritten, it's nice. The problem is, it's just, oh, hey, look, that one's the other way. So it flip-flops back and forth, just so you don't get tired only looking at one side. Anyway. Both of them have their pros and their cons. It is what it is. But let me go back. If you guys want to, this is going to go away. We can also double check it real fast. Does somebody at least have a picture of these? Okay. Let's go back to our, I heard number 6. I heard number 11. And number 4? Okay. Doesn't mean that those are the only ones we'll get to, but we'll just see what time we have. So let's start with number 4. Go to number 6. Go to number 11. Now pause. If you're like, I haven't done any work on this. Well, you could be working on 4 and 6 and 11. Right? And technically it's bonus. When's all bonus due?
Monday.
By Monday. We'll say 4 o'clock. That way you're not here and keeping me till late. Alright, number 4. Oh, I thought you said number 3, and I was like, no way! Anyway. You want to ask me about number 3, hopefully. You know, your forever cards. Yeah.
You know how the bonus tests online, like, do you have to start with the whole thing, or?
I say yes because the questions are bad.
Okay.
It's not that I don't like if you have a study book, you can start there because you can see stuff in the study book. Or if you like the other ones better. So I'm not going to not take the other ones. My advice is just College Board is who makes your AP. So start with their questions. It's probably better, but
Okay.
some people have study books and they've been doing those practice exams. I'll count it. Just my advice. But we all know why number 3 should be easy cheesy as long as we know it for others. Number 4. How do you take a derivative? Derivative of 7x is? Derivative of 3 is?
0.
Derivative of ln is?
1 over x.
What are we plugging in?
1. The answer said E.
The answer said what?
Oh, it's E. I thought it said B.
Oh, so you got it right.
Yeah.
But hey, we don't mind easy points. We love free points. Cheerleading. Alright, so what else do we have? Number 6. Ooh, he might be harder. Ah, but he's motion, and we're practicing motion. Alright, kiddos. Does anyone see anything that points us to a forever card? Louder. Total distance. Right away, your brain hopefully says, if I can, I need an A and I need a B. Hopefully your brain can say, I see a 0, I see a 3. Absolute value, V of TDT. Go team. Now, it's on the AP test, so maybe that's not so easy to do, but at least we have a way to go. Now, here's the struggle. We got to solve them by hand. So not only do we have to remember our formula, but we also have to solve them. Can anybody help me out? I think. How do we handle integration with absolute value? Split up at the zeros. For our area between, we would split up at the intersections, but split up at the zeros if there are any zeros in between 0 and 3. Zeros, yeah. Zeros. Question, do we have any zeros in between 0 and 3? Oh, so what are we allowed to do? Say we don't have to split up at all. We're just going to take the integral from 0 to 3. They were nice to us on this one. The mock AP, they made us split it up on that one, remember? Just got to be ready. Careful integration, make it positive at the end. 6t squared over 2. T cubed over 3 would be 1 over t cubed. From 0 to 3, the big ol' absolute value. Then we go ahead and plug and chug. We end up with absolute value of 3 times 3 squared is 9, minus 1/3. 3 times 3 times 3 is 27. Minus 0, so we plug in 0 minus 0. 27 minus 1/3, 27. Don't worry, we got this. 27 minus 1/3 of 27, isn't that 9?
Yeah.
Final answer? How's D look?
Yeah.
Go team. Next one I have is 11, but seriously, I'll say you want to see first.
This is kind of just like an unfortunate question. For number 5, if a function like jumps, like,
Yeah.
is it still continuous?
Now, hold on, looking real quick. This is the graph of the function, not the derivative, right? Good. It's the graph of the function. So, if a function jumps, 1, the limit does not exist because they don't agree on their y values. The little cars are going different places. So the limit doesn't exist, which is why the function is not continuous at 4. But is the function continuous at 3?
Yeah.
Yeah, no holes in the limits. The cars are going the same place. Okay. Number 11, then Katrina, what'd you say?
Number 8.
Number 8. Okay, let's go peek at number 8 first because it's on the way to 11. And it's a table. Go team. You guys see? Aren't we given rates, liters per hour? We're given rates, liters per hour. Ooh, they give us that the tank begins with 50 liters of oil. Then oil is pumped in. Let's select R's in the table. Using a Wright-Riemann sum with 3 subintervals. What is the approximation of the number of liters that are in the tank? Question, is this just an over question or is it an at question? Are they caring about what is at 15? What amount is at 15? Or do they just care about the over? What's happened over the time? The at. If it's the at, we need to do integration is net change. Not 0. Sorry, we're starting at 4. Now we are going to do the Wright-Riemann sum, but the Wright-Riemann sum is only part of the problem. We need to do how many liters there were to begin with, plus the Wright-Riemann sum, which approximates how much oil was pumped in to the 50 that were already there. So the Wright-Riemann sum, do you guys see your 3 jumpity jumps? And the Wright-Riemann sum, I see my first jump as from 4 to 7 is 3, and we're using the height on the right? 6.2. The jump from 7 to 12 is 5, and the height is 5.9. Jump from 12 to 15 is 3, and we're using a height of 5.6. Some of you are like, no way. They made me do decimals by hand. Yeah. I'm telling you, every now and then there's going to be math. You're going to have to actually do it. But pause. 3 times 6 is 18-ish. 5 times 5 is 25-ish. That'd be, what? 30, 43-ish, and then 15-ish, 43 and 15-ish is 58-ish, that's 100-ish, definitely not the 60s. Then we have to figure out the 100-ish to be precise. Right? So then if you guys need to remember how to do decimals, remember how you can take 6.2 times 3? 2-column multiplication. 3 times 2 is 6. 6 times 6 is 18. I know it's annoying, but it works. Using similar logic, we could go ahead and get 5 times 9 is 45, carry the 4. 25 and 4 is 29. 3 times 6 is 18, carry the 1. 3 times 5 is 15, plus 1 is 16. If we were to go ahead and add each of our decimals together, we would have 8. You could line it all up and do column addition. You can also do 8 plus 6 is 14. 14 plus 5 is 19. Carry the 1. 1 plus 6 is 7. 7 and 9 is 16. 16 and 8 is 24. 24 and 0 is still 24. Carry the 2. 2 and 3 and 4, 5, 6, 6 and 5 is 11. I had my air freshener turned on earlier, but then I wanted to smell the coffee instead because it smelled good, so someone just scripts their emotion or something. Done, not done. Don't be scared of the math. Okay, so number 11. Ooh. What's going on here? Square root and an absolute value. Square root and an absolute value. How fun is it going to be to take the derivative of this? Why am I thinking derivative? Because I see the word differentiable. How fun will it be to take the limit of this? Here's a big question that you have to think about. Bless you, bless you. Does the square root of 0 exist? Ah! Yes? Ah, 0 squared is 0, right? The square root of 0 exists. Why is that important?
If it doesn't, it's continuous with 2.
Says which is true. How would I find the limit as x approaches 2? I'm starting with the easy ones. You don't have to take any derivatives for letter D. The most basic one is letter D, first of all. If I take the limit as x approaches 2, I have to approach from below and from above, right? Now usually it's not a big deal because we just go ahead and plug in. With square roots I have to be a little bit careful because what if something doesn't, what if you have like a domain restriction, it can't come from the left or from the right, etc. But in this one, to take the limit of f of x, can't we just plug it in and say the square root of absolute value of 2 minus 2 is square root of 0, which is 0? And is there any domain restriction if everything underneath always has to be a positive number? No domain restriction. There's no domain restriction. There are no jumps or discontinuities. The square root of 0 is 0. It's not C. C says something's bad's happening at 2. Nothing bad's happening at 2. It's fine. Square root of 0 is 0. Letter A and B get a little bit confusing. Letter A and B get a little bit confusing, talking about the derivative. If we want to take the derivative, we could, just in case some of you guys want to see how that would look like. You could bring down the 1/2. You could make absolute value of x minus 2 to the negative 1/2. The u prime would be the derivative of absolute value of u, which we could do one of two ways. Both ways are good. We could do absolute value of u over u, or we could do u over absolute value of u. Absolute value can be on the top or the bottom. And then times the inside prime, which is just 1. This is a little bit messy, but if we were to keep going, we would have 1 times absolute value of x minus 2. All over, we have a square root. We have a 2. We have an x minus 2. And we have an absolute value of x minus 2. There's all sorts of yuckiness going on. Oh, sorry, we didn't ever mark out letter D. My bad. Letter D says it doesn't exist. The limit does exist. The limit is 0. My bad. I meant to mark that out. Question. Does this derivative exist at 2? Don't you have over 0 at 2?
Yeah.
Oh, the limit might exist, but the derivative doesn't. The limit might exist, but my derivative is undefined. It's going to be like maybe 0 over 0. Yeah, it's 0 over 0. So the limit might exist, but the derivative doesn't. Well, wait a minute. If the derivative doesn't exist, then B is wrong. Oh, well, wait a minute. We said it was continuous. Everything's fine. There's no weird domain restriction. The limit's fine. Not differentiable. Yeah, absolute values, don't they never have derivatives after sharp points? But the formula also proved that. Vertical asymptote, because to be a vertical asymptote, doesn't it need to be in the denominator of the original? There is no denominator of the original, so E is not possible. E is not possible. And even when we do get a discontinuity in our derivative, it's a 0 over 0. Vertical asymptote's number over 0. Unless we apply one. Vertical asymptote, original function needs to have a denominator of 0. We have time, we have a few more minutes. Anything else you guys have found that you're like, pretty close? Yeah, Ellen.
Number 12.
12. Oh, like the monkey pee. I'm a puppet. You guys lead me. What should I do? You don't need me.
So, I'm do you.
Fine, do you? Do I need to start with? Oh, got it. Okay, well, thanks for telling me to find it, but you guys find it.
1/2 x the negative 1/2 equals
Can I do that?
half.
Now what?
Multiply by 2 dx equals 2 root ft. Then you plug in to the integral. And then find the bounds. Two and 1. That will have A, B, and B. And see, we pulled out why it was slotted in.
The 2 came from the dx. Sorry, the d. When we solved it. Can't forget your U bounds. Still have time for another one. 13. I'm just doing problems for you. Oh, it is a piece wise. Why do those make me look here?
You want to see there's right bounds.
Why am I breaking it?
Because there's
3 is in between, so I have to split up. So between 1 and 3, what function am I using? Good. And between 3 and 5, what function am I using? I have to use whatever function is appropriate for the bounds. So now I have 2x over 3. And I have 1/2 x squared plus x. And 2. You guys don't need to do that. Plug in the top, minus plug in the bottom, plus plug in the top, minus plug in the bottom. Carefully. Carefully do your multiplication and addition. Number 14, what rule can't you forget? Ways of doing it. The ways to write f prime of g of x times g prime and plug in stuff. The other way is to actually plug g into f. So that might even get more confusing. It's a little easier just to write the formula out and then plug in stuff. Kind of just depends on your brain as to which one of these. Might be easier to go find the pieces given what they gave you. Technically, it's 60 seconds. Never mind. We haven't made it. Alright, cool kids, I'm gonna stop the video. And I will see you later. Tomorrow we'll go over questions on section B. First, and if you guys don't have a lot, maybe we'll go back to if you have any more on A. Keep studying those forevers. I know you took a forever final, but we gotta keep them until next Tuesday.